right. Okay, so this one was a little bit, this one is, excuse me, it's a little bit different, but again, it's really the same idea. Okay, so here, what we have to do is just like before, we want to make a right triangle where the angle theta is in it, such that tangent of theta is a third. Okay, that's what we want. That's what we want to happen. Okay, well, so again, here's the right angle. I put theta down here. Now remember, tangent of theta, excuse me, is opposite over adjacent, opposite over adjacent, right? And we have tangent of theta is a third. So I'm going to make the opposite side 1 and the adjacent side 3. So in this triangle, tangent of this angle is 1 over 3, opposite over adjacent. So we have tangent of theta is a third, right? So we have a right triangle where this is true. Okay. Now, what about this side, right? This side we don't know anything about, which is the hypotenuse. I'm calling it x. Okay, I'm calling it x because it's unknown. How do we find it? We use Pythagorean's theorem, right? Namely, what we have is 1 squared plus 3 squared equals x squared. Well, if you want, a squared plus b squared is c squared. C is basically x here. I'm taking a to be 3, b to be 1. And so we get x squared is 3 squared plus 1 squared, which is 9 plus 1. So we have x squared is 3 squared plus 1 squared, which is 9 plus 1, which is 10. So x squared is 10. Well, what's x got to be? Take the square root. You get square root of 10. Okay, are there any questions so far? In the chat to see. It's like no one. Okay, that's all right. Just checking the chat to see if anyone typed in there. So no one did. All right, let's keep going. And again, if you happen to put theta up here, wait, no, they can't see that. Up here instead, the only difference is that this would be the opposite side and this would be adjacent. So in that case, you would have the 3 and 1 would be switched if you had theta up here instead. Okay, but we get the hypotenuse is the square root of 10. So this is what our right triangle actually looks like. So just like before, we can get all the other trig functions, right? Sine of theta is opposite divided by hypotenuse. 1 over radical 10. Okay, cosecant, that's 1 over sine, right? What do? You invert this. You get radical 10 over 1, which of course is just radical 10. Cosine of theta, right? What about that? Well, that's adjacent over hypotenuse. Adjacent over hypotenuse. 3 over radical 10. Secant is 1 over cosine. That's radical 10 over 3, right? You turn it upside down. This was tangent. Cotangent is 1 over tangent. 1 over, again, turn it upside down. 3 over 1, that's just 3. All right. Are there any questions on that? Okay. All right. So if you actually look so far, we calculated, like tangent of theta, sine of theta, things like that. but we never took specific values for theta. You know, we never said, what is sine of 30 degrees? What is cosine of 40 degrees? What is tangent of 45 degrees? I mean, how would you calculate those? Well, you have to consider special triangles. For instance, what you can do is consider this isosceles right triangle, right? As I said over here, isosceles, that just means two of the sides are equal. Now, since it's an isosceles right triangle, the right angle is between the two equal sides. It's really just basic geometry. You can actually obtain this kind of triangle if you have a square where all the sides have length 1. Although actually, this is a little bit beyond this, but it really doesn't matter what the length is. Instead of 1 here, I could use any length I want, but that's a different story. And this angle, the right angle, has to be here, because since these two sides are equal, the angles opposite them have to equal each other. So you can't have either of these be 90 degrees. You know, that's impossible. Okay, so we have that. The hypotenuse then is here. It's always opposite the 90-degree angle. Okay, well, just to make this look more like a right triangle we've seen so far, we can rotate this and get this. Okay, that's good. But how would you get the length of C? Pythagorean's theorem, right? Here we have a squared plus b squared is c squared. So in this case, we have a and b are both equal to each other. In this case, they're both equal to 1. So by Pythagorean's theorem, we have c squared is a squared plus b squared, which is 1 squared plus 1 squared, and 1 squared is 1, so we get 2 here. So if c squared is 2, then c here has to be the square root of 2. Okay. And here I'm just saying that these two angles here have to be 45 degrees. As I said before, neither of these can be 90 degrees. That's impossible, because then they both would have to be equal to each other since they're opposite equal sides. But in a triangle, remember, the sum of the angles is always 180 degrees. So that's just basic geometry. But once we have this right triangle, we have 45 degrees here, right? We can now get the trig functions of 45 degrees. And that's what we do here. As you can see, sine of 45 degrees, that's opposite divided by hypotenuse, which is 1 over radical 2. And if you multiply top and bottom by the square root of 2, which is the same as rationalizing, if I remember correctly, I did that when I did square roots, rationalizing the denominator. I think I might have done this example, actually. You end up with this. So 1 over the square root of 2 equals the square root of 2 over 2. And that's what sine of 45 degrees is. Okay. Not only that, cosine of 45 degrees, that's adjacent over hypotenuse. Same thing. It's 1 over radical 2, which is the square root of 2 over 2. Okay. So that's what we get here. Tangent of 45 degrees, I mean, I did it this way. You know, that's equal to sine over cosine. And they're both equal to each other, right? So you get 1 here. Or if you wanted to, you could do this. You could just do opposite over adjacent. That's 1 over 1. And you still get 1. So I just put the values in here. I also rewrote 45 degrees as radians, right? Remember, to get the radians, you multiply by pi over 180. Actually, that should be, no, that's all right. Pi over 180 degrees, I think, if I remember correctly. But you get pi over 4 radians. Okay? Good. And I just wrote that down here. 45 degrees is pi over 4 radians. So You could actually get these in your calculator, I mean in decimal form. You do have to be careful because you have to make sure your calculator is in the correct mode. So, you know, if you type in, if your calculator is in radian mode, if you type sine of 45, you're not going to get this. You have to make sure you're in the right mode. So that's for 45 degrees. Are there any questions on this? Yeah.
So how did you get from sine of 45 degrees is 1 over square root of 2, and then you got square root of 2 over 2?
Right?
How did you get that that's equal to square root of 2 over 2?
Oh, how these two are this equal here, you mean?
Yeah, yeah.
It's just you can multiply top and bottom by the square root of 2. Let me show you. Yeah, let me show you. Here. So here we have 1 over the square root of 2, right?
Yeah.
And we really don't want to, and when you rationalize, that just means you don't want, rationalize the denominator, excuse me. That just means you don't want a square root in the denominator. But we can get rid of it because if we multiply and divide by the square root of 2, like so, this is going to, what is this going to equal? Well, on top, you're going to get 1 times the square root of 2. On the bottom, you get the square root of 2. See if I can draw this right. Times the square root of 2. Do you see that so far? Or?
Yeah, and then the 2 and 2, that's the square root of 4, so that's perfect square, so it's 2.
Exactly, yeah. On the bottom, basically, right, you get the square root of 2 times 2, which is square root of 4, but that's equal to 2. So
you do that because you don't want a radical in the denominator?
right. I mean, if you left it as 1 over radical 2, I'm not going to take points off. I wouldn't do that. It's just that a lot of people, what they do is they write it as radical 2 over 2. So.
Oh, okay.
But it's okay to do that, and basically they're just rationalizing the denominator.
Oh, okay. Thank you.
You're welcome. Good question. Any other questions? Over here, I think I made a mistake. It should have been 45 degrees times pi over 180 degrees. That's what it should have been. It still works out to be pi over 4 because the degree unit cancels. So, but it really should have been pi over 180 degrees. So, sorry about that. All right. Let me just, okay, so let me do the recording.